All right, let's dive right in. Today we're tackling something called a cost matrix. And I have a feeling this is going to be a good
I
one.
think so too, yeah.
It might sound a little intimidating at first, but trust me, it's fascinating once you get into it.
hmm
We've got a really interesting mix of sources for this deep dive, too.
Oh,
We've got university lecture notes, we've got blog posts about network programming in C,
okay.
and even a YouTube video about client-server communication.
Wow, a lot to cover then.
Yeah, so let's untangle all this with our expert.
Sounds good, I'm ready.
Okay, perfect. So I'm looking at this document right now called CSL 332 Networking Lab KTU 2019 Scheme. It looks like a list of experiments for students,
Okay.
and one of them is simulation of distance vector routing algorithm. Could this be where a cost matrix comes in?
You got it. Distance vector routing algorithms, they rely heavily on the idea of a cost matrix to figure out the best way to send data.
Okay, so how does this cost matrix thing actually work?
Well, imagine a roadmap, right?
Okay, yeah.
The cities on the map are like routers in a network, and the roads that connect them are the network connections.
Makes sense.
And then the distances on the map, those represent the cost of sending data between those routers.
So the cost matrix is basically just a table that shows the cost of getting data from one point in the network to another.
Exactly.
Okay.
And the cost isn't always just about physical distance.
Oh.
Yeah, it can include things like bandwidth, latency, or even like financial expenses associated with using certain connections.
Oh, I see.
And then the higher the cost, the less desirable that path is for data to travel.
Okay, that makes a lot of sense. Now, I'm noticing in this blog post about simulating the distance vector routing algorithm,
Yeah.
there's C code that asks the user to input a cost matrix.
Yeah.
And there's even an instruction to enter 9999 for no direct link. What's that about?
Well, that's a clever way of representing an absence of a direct connection. Basically, 99999 acts as infinity in this context. So it means those routers can't communicate directly. The algorithm then uses the cost matrix to calculate the shortest paths between routers,
That,
kind of like finding the quickest route on a map.
so the cost matrix is like the key piece of information that the algorithm uses to make decisions about where to send data.
Absolutely, yeah. It's the foundation for determining the most efficient paths for data to travel across the network.
This is starting to make sense now. But why should someone who isn't a network engineer care about cost matrices? What's the relevance for the average person?
That's a good question. Understanding cost matrices can be beneficial even if you're not, deep into networking. Think about choosing the fastest route on a map app.
Okay.
That's essentially a simplified cost matrix in action.
Oh, interesting.
Yeah, it's taking into account traffic conditions, road closures, speed limits, all those factors contribute to the cost of each route.
So even in our everyday lives, we're kind of indirectly interacting with this concept of a cost matrix.
Yeah, more ubiquitous than you think.
Yep.
And in the realm of networking, understanding cost matrices is crucial for things like network design, optimizing data flow, and troubleshooting connectivity issues.
So this seemingly, abstract concept has some very real-world applications. It's making me realize how much goes on behind the scenes to ensure that data gets where it needs to go smoothly and efficiently.
Yeah, it highlights the intricacies of network design, how seemingly simple ideas like this can have a big impact on performance, but this is just the beginning.
Oh.
Yeah, there are different types of cost matrices and nuances in how they are structured and applied.
Well, now that you've piqued my interest, I'm ready to delve into those nuances.
Okay, great.
It sounds like there's a lot more to explore in the world of cost matrices and their impact on networking.
Definitely.
Okay.
And luckily, we have plenty of source material
Perfect.
to help guide us through it.
Let's get into it.
All right, so what's fascinating is how we define cost in these matrices. That can drastically influence a network's behavior.
Okay, I'm all ears. Give me an example.
Let's say you've got a network with some super fast connections but limited capacity, like fiber optic cables.
Okay, got it.
Think a highway with like high-speed limits but only a few lanes.
Okay, yeah, I got that.
And then you have other connections that are slower but they have a lot of capacity,
Oh, okay.
like a wider, slower road. If your cost matrix only considers speed, the algorithm might overload those fast limited connections.
And then cause congestion.
Exactly. It's like everyone's trying to cram onto that highway, even though the side roads might get them there eventually.
Right.
But if you factor capacity into your cost calculation, you can distribute the data more evenly, even if some packets take a slightly longer route.
So it's all about finding the right balance then.
Yeah.
Choosing the right factors for your cost matrix is like setting the rules of the road to ensure smooth traffic flow.
Exactly. That's a great analogy.
Oh, thanks.
Network design involves considering all these trade-offs: speed, capacity, reliability, cost in dollars and cents.
This is making me realize how complex network management can be.
Yeah.
It's not just about plugging in cables. You're making these strategic decisions about how data flows.
Right.
But I'm picturing like network engineers huddled over spreadsheets, manually updating these cost matrices. Is that how it works?
No, not quite. Luckily, in most modern networks, routing protocols handle this automatically.
Yeah.
They exchange information about network conditions, constantly updating their own cost matrices
Oh, wow.
and adjusting their routing decisions in real time.
So it's like those map apps that reroute you if there's an accident ahead. They're
Exactly.
getting real-time updates on the cost of different routes.
Yeah. And just like those apps, routing protocols can sometimes make mistakes or, get stuck in a loop,
Oh.
especially in complex or rapidly changing network environments.
Okay.
That's why network monitoring and troubleshooting are so crucial.
This reminds me of the YouTube video we have about client-server communication using UDP.
Mm-hmm.
No, that's a different type of network protocol.
Yeah,
Do cost matrices come into play there?
that's a sharp observation. While cost matrices are fundamental to distance vector routing, which is typically used with TCP, they're not as directly relevant to UDP communication.
So different protocols, different rules of the road.
Basically, TCP, or Transmission Control Protocol, is like a reliable postal service.
Okay.
It ensures that data packets arrive in order and without errors. UDP is more like sending a postcard.
Oh, okay.
Faster, more efficient, doesn't guarantee delivery or order.
Gotcha. So because TCP focuses on reliability, it needs a mechanism like distance vector routing.
Yeah.
UDP being more about speed doesn't have the same need.
Yeah, exactly. Now, going back to your question about UDP and cost matrices, while they aren't directly used in the same way, the concept of cost can still be relevant.
Oh, how so?
For instance, a network might prioritize UDP packets based on their source or type, effectively assigning a cost to certain types of traffic to manage resources effectively.
Oh, that's interesting. So even though the specifics are different, the underlying principle of evaluating costs and making decisions seems to kind of permeate different aspects of networking.
It does, and it brings us back to something we touched on earlier,
Right.
the idea that cost can represent financial expenses.
Right. You mentioned that data transmission can have real-world financial costs.
Yeah.
How does that factor into network decisions?
So, in some situations, network operators have to consider the actual cost of transmitting data over certain links.
Okay.
For instance, think about mobile networks.
Okay.
Data roaming charges can be expensive.
Right.
So, a mobile network might design its cost matrix to keep data traffic within its network, even if it means slower speeds or higher latency.
So it's not always just about, like, technical performance then.
Right.
It's about balancing that with economic considerations.
Exactly. And these economic factors are becoming more and more significant as networks grow.
This is really fascinating.
Yeah.
I'm beginning to appreciate how much thought and strategy goes into making sure data gets where it needs to go.
Yeah.
Not just, efficiently, but also cost
Yeah.
effectively. It's like a giant puzzle you're trying to optimize for multiple things.
It is. And the cost matrix, while seemingly simple, plays a big role in solving that puzzle.
Yeah. Okay. We've covered a lot of ground here. Started with this idea of a cost matrix as a map for data.
Yeah.
Now we're seeing how it extends beyond physical distance.
Yeah.
We're encompassing things like bandwidth, latency, even financial costs.
Mm-hmm.
We've even touched upon how different protocols utilize cost considerations differently.
Yeah.
And we've only just scratched the surface.
Right.
There's more to explore in the world of cost matrices and how they shape the internet as we know it.
Yeah.
Well, I'm ready to dive deeper.
Okay, great.
It's clear that cost matrices, while often hidden, are a fundamental element in the complex world of networking.
Definitely.
Yeah. So we've talked a lot about what goes into a cost matrix, but I'm curious, like, on the technical side, how do routing protocols actually use these matrices? I imagine there's a lot of math involved.
Yeah, there is a bit of math involved, but the core idea is actually pretty simple. Remember that distance vector routing algorithm we talked about?
Yeah.
Each router keeps its own cost matrix and shares it with its neighbors.
Right. So it's like they're comparing notes on the best routes.
Exactly. And when a router receives a matrix from its neighbor, it compares it with its own to see if maybe there are any shorter paths.
So like Checking if your neighbor knows a shortcut you haven't discovered yet.
Yeah, great analogy. And if it finds a shorter path, it'll update its own matrix
Okay.
and then passes that information along to its neighbors. This process happens constantly, with each router refining its understanding of the network.
It's like a game of telephone,
Kind of, yeah,
but with cost matrices.
with cost matrices being whispered around instead of words, yeah.
Right, exactly. Eventually, everyone settles on the best routes.
That's the beauty of distance vector routing. It's decentralized, there's no single authority that's dictating the best paths.
Right.
Each router figures it out on its own.
That's impressive. What happens if something changes in the network, though?
Yeah.
Like a connection goes down or a new router gets added?
That's where things can get a bit tricky. When changes occur, it takes some time for the routing protocol to settle on a new set of ideal paths.
Ah, so like those map apps that get confused when you miss a turn.
Exactly.
Take a while to recalculate.
And sometimes those changes can lead to routing loops where data packets just get stuck.
Oh, that doesn't sound good. How do you prevent that?
There's a few different ways to prevent those routing loops. One common strategy is the split horizon rule, which basically stops a router from sending route information back to the neighbor that it learned it from.
So it's kind of like saying, don't tell me what I just told you.
Exactly. There are other techniques as well, things like poison reverse and hold down timers, all designed to help the routing protocol converge quickly and avoid those loops.
So it's this constant balancing act, it sounds like, between stability and being responsive to changes.
Exactly. And that's why network engineering is so challenging and rewarding. You've got to balance all these competing factors.
You've definitely given me a much deeper appreciation for how complex all of this is. I've gone from knowing next to nothing to feeling like I can actually hold a conversation about cost matrices now.
I'd say you've leveled up significantly. And remember, this is just a small glimpse into, the world of networking.
Of course.
There's a ton more to
Yeah.
discover.
Well, thanks to you, I'm motivated to learn more. To wrap things up for our listeners today, we learned that a cost matrix is this core concept in networking, especially in routing algorithms like distance vector routing. It basically acts as a map, to guide data through a network, factoring in things like speed, capacity, even cost. We also explored how routing protocols use these matrices to constantly, exchange information and adjust their paths to optimize performance.
And perhaps most importantly, we've learned that even something that seems simple, like this, can reveal a whole lot of complexity.
That's a great point. As always, we want to leave you with something to think about.
Yeah.
We've been talking about cost matrices in terms of computer networks, but could we apply this concept to other areas of life?
Oh, interesting.
What if we use cost matrices to make decisions about things like project management, travel planning, even choosing a career path? What factors would you include in your cost calculations?
That's a great question. I mean, there are so many situations where we're trying to find the best path through a bunch of choices.
Right.
Maybe a cost matrix could be a valuable tool for navigating those decisions.
Definitely something to ponder. Thanks for joining us on this deep dive into cost matrices, and we'll see you next time for another exciting exploration.
Sounds good.